Okay, so next up, looks like it's Hobbs and Azad. So Will has been added to this event. And he's going to talk about expected energy modeling, and the longer title has something to do with fine-tuning approach and diffuse irradiance data. Okay, Will.
All right. Yeah, so I'm Will Hobbs. My collaborator, colleague, Ishtiza, couldn't be here. He had a family emergency come up last week, which is also when we were planning to do the majority of the work for this presentation. So it was thrown together a little quickly. So there should be an asterisk on each slide that may be further verification needed. Yeah, I'm also noticing the font I picked is not working here, but I think it'll be fine. All right, it seems like everybody was having issues with clicking. What's the trick?
I guess the down button.
Oh, down, okay.
It's different.
That works. Okay, so a little bit of background. So I work at Southern Company in R&D. Ishtiza works at Southern Power, our independent power producer utility, as a performance engineer. But Southern Company in aggregate owns or operates about 2,500 megawatts of PV. And so in general, we model expected energy to benchmark plants. We use on-site weather data and past performance. We do this to do things like look for underperformance, try and find sources of underperformance, use it in reporting, and that sort of thing. And so this talk is about trying to improve those models. I'll say this talk, in contrast with the last few, takes some very, very simple modeling approaches compared to what you've seen. So, oh, my animations didn't load either. I was planning to step this in a little bit at a time and not overload you. But some previous work. So we had a poster at PVRW where we talked about a simple self-shade correction based on some modeling work done previously with Kevin Anderson. But the background there, thin film trackers that have true tracking are going to result in self-shade. So backtracking up, yeah, if you can see that there. So typically with backtracking, oh goodness, and you can't see my POA sensor either. But the POA sensor sees similar irradiance to what the modules see in the case of backtracking. But with true tracking, you have shade on the modules and generally not on the irradiance sensor. And so you can end up with this red scatter here of measured power as a function of irradiance. You see this large curved dip during periods where modules are shaded and sensors are not. And so we wanted to account for that. Oh, no, now it's not clicking again. Other tricks, Josh?
I wonder if we should just stop it and start it again. It's not, it's different. Here, let's try this again. Let's go to here. There we go.
Oh.
Here, try that.
Yeah.
And then click, you have to click here.
Okay.
Just.
Oh, there we go. We got fonts, animations, perfect. There we go. All right, so if we take this shaded fraction calculation, we use a really simple 20% diffuse irradiance assumption, and then apply a linear loss like you might apply for thin film modules. We end up with a better fit of modeled and expected energy, and we can also apply this for a larger period of time because there's about 25% of daylight intervals that would have self-shading. So here's a look at modeled and measured power as a function of irradiance. We see generally pretty good agreement. And then here's modeled versus measured power with the shade correction in green and without in red. And so you can see that if we didn't apply that correction but tried to model all intervals, we would dramatically overestimate power during a lot of the time. So, okay, so that was our poster at PVRW. So what am I talking about now? Well, looking at room for improvement. So one thing that we noticed is what looked like two clusters in our shade-corrected modeled power. And the particular plant that we were using for testing all of this has two different ground coverage ratios within the plant. Some inverters have a high GCR, some have a lower GCR. So we thought, well, what if we model each inverter individually and then aggregate them? And to give you an idea of the inverter level differences, this is measured data for two inverters with the higher and lower GCRs. And just quick background on what ground coverage ratio is, ratio of the width of the PV array to the space between rows. And so this is roughly to scale for the higher GCR, and then this diagram here is roughly to scale for the lower GCR, to give you an idea of what we're looking at within this plant. There's these two approaches. What we previously did is plant level model with a weighted average GCR as an input to our self-shade calculation. And then what we do is a plant level fit for a DC loss factor and a temperature coefficient. And so what we're going to compare that with, this newer approach, is inverter level modeling with inverter specific GCRs, inverter specific fits, and then we sum up to aggregate those inverters. And so what I did is I tested all of this. I used 1 month of 2-minute interval data, and I'm fitting the models using the even number days and then testing with the odd number days. So, you know, we've got a little bit of variation there, not exactly overfitting. So a look at how the model works and how we do the fitting. We're using PVLib's PV watts models, and for a temperature coefficient rather than a spec sheet coefficient, we are doing a fit of the slope of performance ratio versus measured back of module temperature, shown in that diagram down in the bottom there. And we get a guess of a DC loss factor from that, but then we optimize to reduce absolute value of error. And we apply a little bit of filtering. The second one there, no known curtailment. Known is key. I think we might have a little bit of curtailment sneaking into our data that I'll talk about in a little bit, or some other availability issue. So here's the results. We've got plant level models on the left, inverter level models on the right. If I didn't put some error stats up there, you probably wouldn't be able to tell the difference. And if you look closely at those error stats, there's actually not much of a difference, which is not what I expected to find. And then let's see if I can, yeah, there we go. I'll switch back and forth. Can you spot the difference? It's pretty small. So yeah, that's kind of conclusion number one. So far, we're not seeing big differences in these inverter level models, even though we see inverter level specification differences. So then what about improving our diffuse irradiance input? So this simple model that we use, we just assume a 20% diffuse irradiance at all intervals across the whole year. And that's a pretty basic assumption. So we thought, what if we did something a little more advanced, like decompose our irradiance to get a diffuse fraction? This is the same approach that Kevin and I took on a previous paper or poster the year before this one. And yeah, so we want to know, is a more sophisticated model better? At least the way I implemented it, it is much slower. So is that time worthwhile? And I think the short answer so far, assuming I didn't make any mistakes, is that it is not better. The simple approach for this particular site seems to work better. And again, I'll switch back and forth so you can kind of see what's going on. Yeah, so big caveat, the site's more or less in the desert, 20% diffuse irradiance seems to work pretty well. Clear skies almost all of the time. There's a little bit of overcast in our data set, but not very significant. Yeah, so those are two main conclusions. Inverter level models help maybe a tiny bit. Decomposition, the way we did it, does not appear to help. But some possible issues. So a few things. One, most inverters look about like this, which looks about like the plant, measured versus modeled power. But some of them look like this. And so this is all baked into our data set. I didn't exclude inverters like this. I think this is something like stuck values in SCADA or a Pi historian. And so that's adding some noise. There's other general data quality control issues. So that chart I showed before of performance ratio versus back of module temperature. You notice there's some weird scatter at the low temperature range. There's also a few different kind of lines there. I've color-coded this by date. This is the same thing I did in these charts here. So you notice at the top end, above the line, the bright yellow, that's all the most recent data. So something seems to have happened during the tail end of the month where actual power went down, either curtailment that wasn't logged right or some other derate, and it's showing up there. Yeah, so other things to explore or future work. Hope to get to it this time, but just ran out of time. We want to use satellite-based diffuse fraction and also apply a spectral correction for these thin film modules. Obviously could use more data quality control. Also need to confirm the ground coverage ratio values. So we derived them from as-built drawings. We haven't confirmed them on the ground. I've seen differences before in drawings and what's actually built. I did a quick test to optimize for GCR, and I found an optimal GCR was a little bit lower than what we see in the drawing. So I don't know if that's because our model just doesn't work quite right or the actual GCR is lower. And then want to try to apply this for other sites. Would like to look at sites with backtracking and a range of GCRs, see how much benefit we see for inverter level models there. Same thing with clipping. And then of course, this is in the sites in the desert. So things like a simple diffuse fraction might not work as well in other climates. And then we want to look at sites with less soiling. This site has pretty significant soiling fluctuations within the month. And so with that, if you have any questions, shoot me an email. I could probably share most of my code as well if anybody's interested in that. Just don't judge me if you find mistakes. Yeah, and then if you're looking for a job, we need to print this out and stick it on the wall back there. But Southern Company's hiring, yeah, I'd be glad to chat with you about it, or Kelly Novak is back there. You could chat with her. It's on her team. Thanks, and I'll throw this up. This is what soiling looked like throughout the month, so it's a bit all over the place. Yeah, thank you.